Okay, here we go with Unit 2. So we're going to start off with some vocab, so beginning with quadratic functions. So this whole unit is about quadratic functions, which you have seen before. But they have this parabolic shape, and the key characteristic is basically it has x squared. So when we think about a quadratic function, there are a couple different ways we can write that. So we have f of x equals ax squared plus bx plus c, where a, b, and c are just coefficients, just numbers. And this squared piece is kind of how we indicate that it's a quadratic function. The other way we'll write quadratic function, and this is using vertex form, is f of x equals a times x minus h squared plus k. Where, in this case, h and k represents your vertex, which the vertex is your highest or lowest point of a parabola. And we refer to those highest and lowest points as maximum would be the highest point, and a minimum would be the lowest. Those are words you've seen before as well. So with these quadratic functions, they either have a vertex that's the minimum, the lowest point, or in some cases a vertex that's the highest point. In addition to that, some other things we look at in terms of characteristics are x-intercepts, which are essentially points where the function crosses the x-axis. The directionality refers to the direction of your quadratic function, of your parabola. Then there are two options. It either has upward directionality, it's pointing up, and in those cases you have a parabola like this, like the one over here, or you have a downward facing parabola, which is just the opposite. The arrows are pointing down. Last term here we have is axis of symmetry, which we can describe as the line that divides or cuts the parabola into reflected halves. So as we're thinking about the axis of symmetry, it always goes through the vertex, like so. So this would be our axis of symmetry. And the way that we find our axis of symmetry, especially in reference to this first function, is it is x equals negative b over 2a, which is something we won't get to exactly in this set of notes, but in one later on this unit we will. Okay, so the focus for today is going to be identifying these vocab words, identifying these pieces from a graph, so visually. So as we look here, let's just start by finding the vertex. So the vertex is that lowest or highest point. So in this case, it is at 1, negative 6. So our vertex will be the point, 1, negative 6. And then we're just referring to, is this a maximum, is it a high point, or is it a minimum, a low point? In this case, it would be a minimum. Okay. All right, so let's identify some of these characteristics here for a couple of graphs. So we'll start with this one on the left here. So for both instances, it says, please identify the key characteristics of the following quadratics. So starting with the vertex. The vertex is either the highest or lowest point. Our highest point is right here, which the x value is -1, the y value is 4. So we would say we have a vertex of -1, 4. This point is a high point, so we would call it a maximum. The x-intercepts, well, those are where your function crosses or touches the x-axis. So that's this one here. So it touches at 1 and at -5. So these are points. So this first point here at 1, it'd have an x value of 1, a y value of 0. Over here, sorry, that's -3, an x value of -3 and a y value of 0. And this function, it is pointing down. So we would have a downward directionality. Last thing we have is the axis of symmetry, which is the line that cuts through your vertex, cuts it in half. And the way we represent this line is it's always x equals. That's how we represent vertical lines. And it's just x equals whatever point it crosses through. So it crosses through -1, so it'd have an axis of symmetry of -1. Before we move on to the next problem, there's one thing I'd like for you to notice here. So you'll notice the axis of symmetry and the vertex have the same value. That's because your axis of symmetry always goes through the vertex. And that will always be the case. The x value of your vertex will always be this value here in your axis of symmetry. But this is an equation, it is a line, so it needs to be represented as x equals -1. You can't just write like -1. That's wrong. That's just a number. You need to write the axis. Okay. All right. Let's look at another together. Over here, so start by identifying the vertex. So that's our high or low point. So it looks like we have a point at -2. Right in between here looks to be about 3. So we have our vertex at -2. Or sorry, it's always x value then y value. 3, -2. Excuse me. This is a low point. It's a minimum. The x-intercepts, so we look for where does it cross the x-axis. So I'm noticing these tick marks. They're going 0.51, 1.5. Actually, maybe different than that. So halfway between, this would be about 1. Looks like they're going by, I don't know. They're going by 0.4, I suppose. So 0.4, 0.8, 1.2, 1.6 would be that point. So x equals 1.6. Over here, so we got 2 there. We've got 2.4, 2.8, 3.2, 3.64, 4.4, roughly. Directionality, this one is pointing up in the axis of symmetry. It's the line that goes through your vertex, and it's always x equals the x value of your vertex, or x equals 3. So notice those connections. Okay. All right. You've got 2 more here. What I'd like for you to do, please go ahead, try both of those problems on your own, pause the video, and please give them a try. Okay, we're back. For the first one here, -3, -10 is the vertex. Our vertex is a minimum. We have x-intercepts at roughly 0.20 and -6, 0. Our directionality is up, and our axis of symmetry goes through x equals -3. For the other one, we have a vertex at 1, 4. This is a maximum because our vertex is a high point. We have intercepts at -1, 0 and 3, 0. Directionality is down, and our axis of symmetry would be x equals 1. Okay. So there's describing. Last thing we need to be able to do, or at least want to visit here, is graphing. And to do so, being able to plug things in, being able to use tables and such is very valuable. So what we'll do here is we want to plug in each of these values for x and solve for f of x. So like for -5, you plug in -5 for x. So -5 squared is 25. 6 times -5 is -30. 25 minus 30 is -5, plus 9 is 4. So when we plug in -5 for x, we get an x value of 4. From there, we can continue here. Plug in -4 for x. So when you plug in -4, you get -4 squared plus 6 times -4 plus 9. Negative squared, or negative times negative, remember, is positive. 6 times -4 is -24. 16 minus 24 is 8. -8 plus 9 is 1. So we get 1 when we plug in -4. So then you can go ahead and do the same thing for each of these. So pause the video, do the same for those. Okay, we're back. So you should get 0 here, 1 here, and 4 here. Okay, so now we could use that information to help us graph. Before we do that, let's just kind of revisit this idea here and try to at least make it a little simpler. Because we can evaluate quadratics using our calculators, which is kind of nice. So the way we do that is you start by plugging in your function for y equals in your calculator, and then you access the table using second and graph. And then you can scroll to find the x values and match them up with the f of x values. So why don't you go ahead and try that? Okay. So these are the values we should get. Okay. All right. Let's put it together here. So doing some of that, we're going to start by graphing here and then describing these characteristics. So go ahead first, and we'll want to evaluate these points. So you can plug in your function into your calculator into that y equals, hit second graph to find the table feature, and then match up your values. So when we plug in 1, we should get 3, 2, 0, 3, -1, 4, 0, and 5, 3. So what we can do now is we can graph these points. So we have a point at 1, 3, at 2, 0, at 3, -1, at 4, 0, and at 5, 3. And that looks a lot like a parabola to me. So there we have our parabola, and now we can determine these characteristics. So remember, the vertex is that low point, so 3, -1 is our vertex. Our vertex here is a minimum because it is a low point. It's pointing up because the arrows are pointing up. Our x-intercepts are at 2 and 4, so we describe those as 2, 0, and 4, 0. And our axis of symmetry, that line that cuts through our vertex, is x equals 3. And there we have it. So we're just putting together a couple of different things. Okay. All right, you've got one more. Read through it, try it on your own, and then we'll check back in, make sure you've got this down. Okay, we're back. After you plug in those values, you should get 0, 3, 4, 3, 0. Vertex is 3, 4. I suppose we can graph first. So we have 1, 0, 2, 3, 3, 4, 4, 3, 5, 0. It is a high point, so it's a max. It's pointing down, so our directionality would be down. Our x-intercepts are at 1 and 5, so 1, 0, and 5, 0. And our axis of symmetry would be x equals 3. And there you have it. Those are the things we need to find for quadratic functions.